Hey everyone, and welcome back to hopefully our final tutorial in the Tetris Clone series. I am Chris, and we are going to go ahead and get started. So the first thing we're going to do is we're going to go ahead and open our game class. And let's see here. Okay, so where we left off last is we've added the ability for our Tetraminos to fall, land on the ground, and land on each other, and update our grid array with every move, every successful move. So what we need to do next is we need to actually be able to clear rows as we fill them up, right? So I mean that's basically what Tetris is all about, is completing rows and getting points. So the way that we're going to do this, and oh, you know what? By the way, let's go ahead and delete this update method from our game class, just because we don't actually need it at all. All the Tetraminos are basically self-sustaining. They update themselves. So the class has got nothing to do with their movement or behavior. So the first thing that we actually need to do in order to get this started is we need to check and see if any of our rows are full. And this is actually something that will get called every time a piece has landed. So once a piece lands, we're going to create a method called isFullRowAt, and we're going to pass it the position of the piece that's landed. It's going to iterate over every possible x coordinate in the y coordinate row that we're in. So let's go ahead and just start writing that out. So public, it's going to return a bool because we need to know if the row is actually full. Okay, we're going to pass in y as for the row that we want to check. Okay, so we're going to create a for loop, and this for loop is going to run from 0 to the width of the grid. Okay, and basically what we're going to do here is we're going to check our grid array at the x and y position, and we're going to check and see if it equals null. Okay, if it does, then we're going to return false, because obviously the row is not full, because if we're returning false for one of our positions in that row, then there's no transform there at that position in the grid array, so we have to return false. Otherwise, if we go through the entire for loop without returning false, we want to return true, which indicates that we do have a full row. Okay. Now, the next method that we're going to need is we're gonna create a method named deleteaminoat. Okay, and I'm going to explain how this works. First, it's going to not return anything, and deleteaminoat is what we're going to call it. Oops. And we're going to pass in y. Okay. So obviously we can't delete amino at y without an x, so we're going to have to iterate over all the x positions. Okay. And the x positions are going to iterate from 0 to the grid width again. And here we're going to destroy grid at the xy position, that game object of the transform that's at that position. Okay, and then we're going to set that position to null in the grid array. Okay, this method right now we're not even calling this, but this method is required for one of the other methods we're going to create, and I'm going to cover all of these once we create them. The next method we're going to create is called move row down. Okay, so because we're also going to want to move our row down, and we're also going to pass in a y. Okay, and we're going to again iterate over the x positions from 0 to the grid width. Okay, and for every iteration, going to get the xy. I'm going to check if it doesn't equal null. Because if it does, then we just don't want to do anything. And if it doesn't equal null, we want to decrement. Actually, we're going to want to put our current transform at our xy position to just one y position lower than what it's at now. And then we want to set the current to null. And then we actually want to position that transform to reflect its new position. One down from where it was. Okay, so because we're moving the row down. Okay, I'm gonna, like I said, I'm gonna go over all of these methods when we're done. Okay, so then we have this method. It's called public void move all rows down, and pass in a y. And for every time this method is called, I'm going to iterate over all the y positions up to the grid height. And for each, we're going to move the row down at the I position, at the index. Okay. And finally, we have delete row y equals 0. So basically what we're doing here is we're iterating over all of the rows, and we're checking each row if it's full. That's where that is full row at method that we just made, the very first one. That's where that comes in. So if the row is full, then we want to delete Mino at y, at the row that we're in, right? We want to delete Mino at. Basically what that does is deletes all the Minos that are in that row, okay? And once all of the Minos have been deleted, we want to call move all rows down, y plus 1. Okay. And then because we've moved one row down, because this row is full, we're actually going to decrement y because we're actually deleting it, and we have to go to the next one, which will be the one that was before. So we delete the Mino at y, okay? So we call this method here, delete Mino at, we're passing in y, we're iterating over our x to the grid width of our grid array. In any game object, we're checking to see if it's null. Or actually, no, we're not. We're setting it to null because we're deleting all of these. So we're deleting all of them. We're setting their xy transform into the transform at each xy coordinate or index in the array. We're setting that to null, so that the position in that array is now equal to null. Okay. And then after we delete those, we call move all rows down y plus 1. Basically what that does is we're starting with the row that's above the row that we're at, okay? So we're moving down, move all rows down. I equals y, basically we're passing in y as this value here. Then this gets set to that, and that's a starting point for where to start moving the rows down from. And then basically we're just going to iterate all the way to the height of the grid, because everything that is above we want to move down. So then we're going to call move row down and pass in I, which is actually y. And then y, we're going to iterate basically over this row that we're passing in. We're going to iterate over all the x values in our grid array we're going to check and see if the value is null or not null. And if it isn't null, then we're going to assign the current transform at our current x iteration and the y row we passed in. We're going to assign that to one y value below and then set the current transform at our xy positions in the grid to null. And then we're going to update our actual position of our transform to reflect its new position after it's been moved down one row. And all of this, of course, will happen instantaneously to the player, because they'll just see the rows going down after the for loop runs, because the for loop runs in the same frame. So it's going to move all these pieces down at once. Okay. So basically, these are all of our methods. So now, the only method that we need to call to get all this started is the delete row method. That's going to start this whole entire process for us. Okay, so the delete row method is actually going to be called from within our Tetramino class. And you guys just take a guess as to where we're going to put this. I'll give you a hint. It's when our Tetramino piece falls, when we set it to, when we disable it here. Enabled equals false, right? Because that's when we know that a piece has landed, and that's when we want to check to see if, because this piece landed, is now, do we have a full row? So I know delete row sounds kind of misleading, because it almost sounds like we're going to delete the row even though, you know, the piece has landed and whatever. But, you know, when we call delete row, before we actually delete the row, we check to see if the row is full. Okay, so right here, after transform that position is set, we're going to go ahead and add in find object of type game, and then we're going to call our not update grid. We're going to call our delete row method, and that's going to start the whole process of deleting a row. It's going to check to see if the row is full. If the row is full, it's going to move down all the minos by iterating over all of the positions in the x coordinates, depending on which row it's currently trying to delete. So at this point, we should have all the code that we need in order to run this game and play it, just like a real Tetris game. The only thing really that's missing here now is keeping score, and you know, I think I'm going to leave that up to you guys to implement and have fun with. So let's go ahead and give this a try. It's been a long tutorial series, and actually not really that long, but I mean it's a pretty lengthy. So let's go ahead and click play, and here's our first piece. Let's see how good we are. See if we can actually create a row to delete. And yes, I'm setting myself up for a long piece, even though I get no extra points. I get no points at all, actually. That'd be a good time for a square. And of course I'm not going to get that. So, but I do have this. And, oh, look at that. Now I get a square. What? Let's just... Oh, long piece would so be good right now. A long piece. There, alright, so these rows here, these two, are going to be full. So they should be deleted, and everything above should move down by 2 rows. There. Perfect. Alright. This time, this row here should disappear, and all of these pieces should move down by 1. Perfect. We now have the start of our very own Tetris style game. So, what sort of things do you do to improve this now? There are a couple of things actually that I would recommend, and one is that there should be some kind of way to keep track of score. Oh, we're gonna get 4 rows. Okay, so there should be some kind of way to keep track of score. And score should be not just like, oh, 5 points for every piece that comes down, or whatever. It should be dynamic. Like, if you clear 1 line, you should get a specific amount. If you clear 2 lines, you should get a little more. 3 lines, a little more. 4 lines at once should be like a really big bonus. And of course, for every piece that lands, depending on which piece it is, could have a different score. And let's see what else. Oh, what else would be nice is if we added a preview window for the next piece, because we're already all we'd have to do really is go ahead and spawn another Tetramino along with spawning our next Tetramino and disable it. And then when it comes time to actually put that one in play, we'll just, instead of spawning a new one, we would just enable it and then go ahead and spawn the next one and set that one to disabled. So it would take a little bit of thinking, but I'm sure you guys could figure it out. Figure it out. It's really not that complicated. If you need some help, I'd be willing to help you guys out or give you guys some ideas of where to start to implement something like that. Previews are good because then you can really anticipate, what you should do with the piece that you've got now. There's also a lot of the Tetris games now, they use what's called like a holding space, where you get specific pieces that you think you might want to use later, so you could save them for later by pressing another key like the space bar or something. You could actually save those pieces and it would go ahead and spawn or release the next piece for you. And if you don't like that piece, you can alternate back to the other piece. That's something else that you could possibly implement too. Another thing, sound effects. Right now there are no sound effects in this game, no background music, no sound playing when you're rotating a piece, when a piece lands, when you're clearing lines. All those things can be implemented and not very overly complicated. Some things, of course, a little more complicated than others, but for the most part, anything like this should be doable. And like I said, I'd be willing to help out with anybody who's got questions or ideas and wants to do something special here. So if you got questions, just let me know. Otherwise, just have fun with it. Make it your own. Create your own graphics if you want. You guys know how to create the prefabs and how to go from there. Other than that, that's basically it. So hope you guys had fun. Hope you learned a lot. So if you guys have any questions, feel free to shoot me an email. I'll try to respond as quickly as possible. Other than that, that's basically it for this tutorial. Actually, the whole series is now complete, so feel free to move on to the next part.